Hello everyone. In this video, we are going to discuss about method in data structures. This is the basic outline of this video. This video consists of introduction to method along with examples, a simple C program, time complexity for method, recurrence relation, and applications of method. Before we start this video, please like this video. It will help me to do much more useful content. So now let us see what is the introduction, what is meant by method. Method is a popular sorting algorithm known for its efficiency and stability. It follows a divide and conquer approach. Here divide means we divide the input array into subarrays, and conquer means we again match those arrays. It works by recursively dividing the input array into two halves, recursively sorting the two halves, and finally merging them back together to obtain the sorted array. This process is known as divide and conquer. So let us consider an input array of four elements 70, 30, 50, and 10. The first step is to divide the input array into two equal halves. After dividing, we obtain two subarrays consist of two elements each. One is 70 and 30, and another one is 50 and 10. Again, we repeat the same process. That is dividing the subarray into two halves. After dividing, we get 70 and another subarray 30. After dividing the subarray 2, we'll get 50 and 10. So no more dividings are possible. So now again we will combine them after sorting. So now we'll compare 70 and 30. Here 30 is smaller. So 30 is first and after followed by 70. Again same process here. We'll compare 50 and 10. Here 10 is smaller. So first element is 10 and the next element is 50. So repeat the same process. Here compare 30 and 10. 10 is smaller. Again compare 30 and 50. 30 is smaller. After again compare 70 and 50. 50 is smaller. And finally the remaining element is 70. So the 70 is inserted into the array. Now let us understand clearly with another example. Let us consider another input array consists of four elements 38, 27, 43 and 10. The first step is to divide the input subarray into two equal halves. So we have total four elements. To divide into two equal halves, we divide 4 by 2 into two elements each. So 38 and 27, 43 and 10. Now let us look into this second step. Splitting the subarray into two equal halves. Again we have 38 and 27 as one array. So total two elements. 2 by 2 means one element each. 38 and 27. Again 43, 10 is divided into 43 and 10. So now step 3. Merging unit length cell into sorted array. So the merging process, we consider two pointer variables, let it be I and second variable be j. So now let I be 38 and j be 27. Compare both I and j, 38 and 27. Here 27 is smaller. So we will pass that value into the new array and increment the j value. So the remaining element is I. So I is passed into the array. The same process is repeated into the second subarray. Let us consider a pointer called I and second pointer called j. Compare both I and j. Here j is smaller, so pass the value into the array and the remaining value is passed into the last element. So now observe the step 4. Again merging those two sorted arrays. Again let us consider two arrays, two pointer variables I and j. Let I be 27 and j be 10. Now compare both I and j. Here j is smaller, so pass that value into the new array and increment the j value. Now j has 43 and I has 27. Compare both I and j. Here 27 is compared with 43. 27 is smaller, so pass 27 into the new array and increment the I value. Now I value has 38 and j value has 43. Compare both I and j. Here I is smaller because 38 is smaller than 43. Now pass that I value into the array and increment the I value. Now here I value is 3, I mean 2, and j value is 1. So the only remaining value is 43, and 43 is passed into the array. So this is the sorting process in the method sort. Now let us execute a simple C program in the C compiler. meth sort code. Let us try another input. Let us consider 5 elements of the array: 40, 30, 80, 50, 10. So the final meth sorted array is 10, 30, 40, 50, and 80. Initially, we declared a meth sort function. This meth sort function has total 5 parameters. For the first parameter represents an array. The second, third, fourth, and fifth parameters represent the first element, last element of first subarray. Second, first element and last element of second subarray. Here, what is meant by subarray? The input array is divided into two equal halves. Let first half be subarray 1 and second half be subarray 2. Inside the main function, we used another function called division function. It consists of three parameters. In the first parameter has array, second parameter and third parameter has 0 and n minus 1. Represents the 0 means first element of input array and last element of input array. We scan the input, we scan the number of elements in the array, and we apply division function. This division has a means array, 0 means first element, n minus 1 means last element of the input array. Inside the division function, if L is less than H, here L has 0 and n value H has n minus 1. So this condition satisfies for the first iteration, first recursive call. We calculate the mid element and we again recursively call division function. So in the first recursive call, we call input array, first element until mid element. In the second recursive call, we call input array, mid plus 1, and the last element of the array. And finally, we apply meth sort. See, as I said earlier, the meth sort has 5 parameters. The second parameter represents first element of first subarray. Middle element, mid stands for last element of first subarray. Mid plus 1 stands for first element of second subarray. And so on. H stands for last element of second subarray. Inside the merge function, we initialize I, J, K values. Here I is the first element, J is the first element of second subarray, K is 0. Well, I is less than or equal to H1 and J is less than or equal to H2. Here H1 and H2 are the last elements. So until that we compare both the elements and pass the element into the new array called temp. Here temp is a new array. We will pass those value and increment the I value and K value. So this is the simple code. If you want the code, I will visit the description. The code will be there. So let us see the time complexities. The best case time complexity has omega of n log n. Average case has theta of n log n, and worst case has big O of n log n. Here all the time complexities are similar. Here log n stands for if the input array size increases, the time complexity keeps on increases. So this is the time complexity of method. Now let us see recurrence relation. The recurrence relation of a method is T of n is equal to theta of 1 if n is equal to 1. Suppose if the input array has only one element, then the recurrence relation time complexity has theta of 1. If n is greater than 1, if we have input array greater than 1 elements, then we have 2t of n by 2 plus theta of n. Here 2t of n by 2 stands for recursively sorting the two subarrays. N by 2 stands for half of the input array. Here 2 stands for 2 times of half of the subarray. Theta n is used for merging the sorted arrays. So this is about the recurrence relation. Now let us see applications of methsort. Methsort is used for sorting the large data sets. It is also used to solve problems like Inversion counting counts smaller on writer and subpasser count. It is a perfected algorithm for sorting linked lists. It can easily parallelized as we can independently sort subarrays and then merge. This is the way we use in merge sort. We sort the subarrays and finally merge them. The merge function of merge sort to efficiently solve the problems like union and intersection of two sorted arrays. So this is about the applications of the merge sort. I hope you liked the video. Thank you for watching. Please like, share and subscribe. If you have any doubts, please comment. Thank you for watching.